Okay, here's example 6 with right triangle trig. So this is going to be a lot like example 5. So example 6, given cotangent of alpha equals 1/7, find the exact values of the following without drawing a triangle. So just like in example 5, we're going to do these with identities and not drawing right triangles. So part A, cotangent of pi over 2 minus alpha. Part B, cosecant of alpha. And part C, cosine of alpha. Okay, so part A, let's do that first. So that's going to be a complementary angle theorem thing, right? So remember, the complementary angle theorem says co-functions of complementary angles are equal. So remember that from a few videos ago. So part A, we want the cotangent of pi over 2 minus alpha. Okay, so the complementary angle theorem tells us that this equals the tangent of alpha. Okay? The complementary angle theorem says the cotangent of pi over 2 minus alpha, which is what we're looking for. Okay, that's what we're looking for. We're told or the complementary angle theorem tells us that equals tangent of alpha. Well, we don't really know tangent of alpha, right? All we know is the cotangent. Well, can we relate these guys to each other some other way besides this identity? Yeah, there is another way. Remember the quotient identities and the reciprocal identities. So in this case, it's going to be a reciprocal identity. So remember, tangent and cotangent, they're reciprocals of each other, right? So tangent of alpha is 1 over the cotangent of alpha. Okay. And if cotangent of alpha is 1/7, then 1 divided by that, and in other words, the reciprocal of the cotangent of alpha is going to be the tangent of alpha, and the reciprocal of 1/7 is just 7. Okay. So that's it for part A. Okay, so cotangent of pi over 2 minus alpha is 7. Okay, so this equals 7. So again, just to recap real quick, first we use the complementary angle theorem to tell us, okay, cotangent of pi over 2 minus alpha, that equals the tangent of alpha. Well, I don't know the tangent, all I know is the cotangent of alpha. Well, hey, tangent of alpha, that's 1 over the cotangent. So if the cotangent of alpha is 1/7, then the tangent is 7, and the tangent equals what we're looking for. Okay. So that's part A. Now part B is the cosecant of alpha. Okay, so that's the cosecant of alpha we're looking for now. Okay, so the cosecant of alpha. So how are we going to get the cosecant? What do we know? We know cotangent of alpha, and we know cotangent of pi over 2 minus alpha, which in turn is the same thing as tangent of alpha. So technically we know cotangent and tangent. So how's that going to help us? We want the cosecant. Is there some relationship between the cosecant and the tangent, or the cosecant and the cotangent? Well, yeah, there's one between cosecant and cotangent, right? So remember the Pythagorean identity. It says, well, there's 3 of them, and one of them says cotangent squared of alpha plus 1 equals cosecant squared of alpha. Okay. So when we talked about the Pythagorean identities, I believe we use theta, but it doesn't matter what you call the angle, it's just a variable name. So you can call it alpha, theta, beta, gamma, x, y, z, t, whatever you want to call it, does not matter at all. It's just an identity that's true, no matter what kind of angle you have there. Okay, so cotangent squared of alpha plus 1 equals cosecant squared of alpha. So that's good. So cotangent of alpha is 1/7, so this is 1/7 squared plus 1 equals cosecant squared of alpha. So 1/7, you square that, you get 1 over 49 plus 1, that equals cosecant squared of alpha. Okay, so 1 over 49 plus 1, so let's do this. 1 over 49 plus, if we get a common denominator, that's going to be 49 over 49. Okay, so this is 1 over 49, so this is like 1 over 1, so we just have to multiply by 49 over 49. Or in other words, 1 is the same thing as 49 divided by itself. So either way, common denominator is 49. So cosecant squared of alpha equals all that still. So now 1 over 49 plus 49 over 49 is 50 over 49. Okay. And we're officially out of room here, so let's come back up here. Okay, so where are we? So we have 50 over 49 equals cosecant squared of alpha. So I'm going to switch sides here. I'm just going to write the right hand on the left and the left on the right. It's just inequality, so of course it's totally fine to do that. So cosecant squared of alpha equals 50 over 49. Okay, so let's go ahead and take a square root of both sides. So remember, there's a positive and a negative root, but since alpha is an acute angle, then cosecant of alpha is going to have to be positive. Why is alpha acute? Because we're talking about right triangle trig. So that means trig of acute angles. So cosecant of alpha is the positive root 50 over 49. So we can rewrite this as root 50 divided by root 49. Okay. Now, first of all, root 49 is just 7, right? So we're just going to have a 7 on the bottom. And root 50, 50 is the same thing, so let's come down here. We use a different color. So root 50, that's the same thing as root 25 times 2, okay? Which is the same thing as root 25 times root 2. Root 25 is just 5, so this is 5 root 2. Okay? So square root of 50 is the same thing as 5 root 2. So that's just some algebra review there. So this is 5 root 2. So cosecant of alpha is 5 root 2 over 7. Okay. And again, we use the Pythagorean identity here to get that. And then we just simplified, we took a square root here. Remember that since alpha is acute, the cosecant and all the other 5 trig functions are going to be positive for that alpha. And we know alpha is acute because we're talking about right triangles. So cosecant of alpha equals 5 root 2 over 7. Okay, so last is cosine of alpha, so that's going to be part C, cosine of alpha. So we'll erase all this over here. Okay, so for cosine of alpha, a couple different ways we can go. So cosine of alpha. Okay, so what do we know? Well, we know the cotangent. We know the tangent also. Well, for part A, cotangent of pi over 2 minus alpha, that's the same thing as the tangent. We know the cosecant, okay? And that's pretty much it. So there are a few different ways we can go about doing this. Really, maybe 3, maybe even 4 different ways, but let's do it one of the simpler ways. So cosine of alpha, cosine of alpha divided by the sine of alpha equals the cotangent of alpha, right? Well, let's see. Cosine of alpha divided by the sine of alpha equals the cotangent of alpha. We know the cotangent. Do we know the sine? Not really, but we do know something related to the sine. We know the cosecant, okay? So we could take the reciprocal of the cosecant to get the sine, but let's not do that because we're dividing by the sine. So let's do this. Let's say cosine of alpha times 1 over sine of alpha equals cotangent of alpha, okay? So what do we do here? We just pull the cosine off the top. Okay, so cosine of alpha divided by sine of alpha, that's the exact same thing as cosine of alpha times 1 over sine of alpha. Just like 2/3 is the same thing as 2 times 1 over 3. Okay, so you can just pull the numerator off the top there and leave it off to the side and you'll have a 1 left over. Okay, so that's the only thing we're doing over here. Okay, now cosine of alpha is just cosine of alpha. Okay, that's what we're looking for. Now 1 over sine, what is 1 over sine? 1 over sine, that's the cosecant of alpha, right? That's cosecant of alpha, okay? So cosecant of alpha, and then cotangent of alpha still over here, okay? Now this is great because we know the cotangent, right? And we know the cosecant. Okay, we were given the cotangent and we found the cosecant in part B, so since we know this and we know this, we could use them to find this. So that's great. Okay, so now cosine of alpha times, what is the cosecant? It's 5 root 2 over 7. Equals cotangent of alpha, which we were told is 1/7. Okay, that was given to us in the problem. So this equals 1/7. Okay, so now we divide both sides by 5 root 2 over 7. So this is going to be cosine of alpha equals 1/7 divided by 5 root 2 over 7. Okay. Okay, so 1/7 divided by 5 root 2 over 7, so that's the same thing as 1/7 times. So if you're dividing by 5 root 2 over 7, what are you really doing? What are you multiplying by? You're multiplying by the reciprocal, which is 7 over 5 root 2. Okay. So the 7's cancel, and then that leaves you with 1 over 5 root 2. Okay. So 1 over 5 root 2 is what cosine of alpha is. So cosine of alpha equals 1 over 5 root 2. Okay? But again, if you have to rationalize the denominator, or if you insist on doing so, then let's see what that would be here. So we can erase all this. So let's recap what we did real quick. Cosine of alpha. So there's a few different ways to approach this. But what we said was, okay, let's use the quotient identity. Cosine of alpha divided by sine of alpha equals cotangent of alpha. Okay? So then we pulled cosine off the top. We said cosine of alpha times 1 over sine of alpha is the cotangent of alpha. 1 over sine is the same thing as the cosecant. Okay, so then we have cosine of alpha times the cosecant of alpha equals the cotangent of alpha. Well, we know the cosecant and we know the cotangent, so basically we're just solving this simple equation here. So this thing we don't know times a number equals another number. Okay, so divide both sides of the equation by this number here, then we just end up with that thing we don't know equals this number. Okay, so let's rationalize the denominator now. And again, there were other ways to approach part C. So if we want to rationalize the denominator, we have 1 over 5 root 2. So multiply the top and the bottom by root 2. And then we end up with root 2 over, so 5 times root 2 times root 2 is 2. So then we end up with root 2 over 10. Okay. It's root 2 over 10. Okay, so if you want to rationalize the denominator, or if you have to, then you'll end up with this. So maybe this does look a little more compact than this, but really it just depends on the application or what you're doing, what you want to do with this number. It really depends on that. Or if you have to rationalize the denominator, then you'll end up with this answer here. But either way, this is example 6 with right triangle trig and evaluating trig functions.